It's great to see good numbers of folks here. One never has a one never knows, how many people register and how many people say they'll be somewhere, but you never know how many are actually going to show up. So we will ask you to keep your mute button on. For various reasons, we couldn't mute everyone at the beginning. So just please do it yourself. And welcome to the first PIANC USA webinar of 2026. This is a bit of an experiment where it's free, and we're very excited to have you there. And you'll still get your credits. So we'll just keep track of the participants who's on there, and in theory, we'll email you your certificate for your one credit for the course. We're going to wait till after the two talks to do the questions because they're actually quite related. They flow together. So I'm going to have a few minutes at the beginning just to talk about PIANC and PIANC USA for those of you who aren't familiar. And then we'll go right into to Burton and Kyle's talk, and they'll introduce themselves. And if we do things right, we'll have maybe 10 minutes at the end for question and answer. And then I know at least Kyle, I think Burton as well, will hang around for some minutes after the hour for those who have a few more questions that didn't get answered. So with that, I'm going to see if I can successfully share my screen. That's always exciting. And yeah, okay, it's that one. So are folks looking at a PowerPointy looking thing? Burton, maybe? We're good. Okay. So I do just want to take a few minutes on this for folks who don't know about PIANC. PIANC is a very strange acronym for the World Association for Waterborne Transport Infrastructure, or sometimes called PIANC International. And then each country, not each country, but many countries have their own sections. And so ours, we just call PIANC USA or something like that. And that has a special Army of Engineers who's been leading the engagement since at least 1902. So with that, there are a lot of good reasons to be a part of it. Some of you belong to ASCE or other professional organizations, and wherever you are in your career, there's a lot for you there. And you can see lots of countries here. I don't see Colombia here, but I know there are some. They do have a national section, and there are some Colombians on the line here. So it helps you, it gives you a chance to get to know some folks around the world. And if you can contribute, the PIANC creates reports from these working groups. Burton has participated in many of them, and Kyle has as well. And these are just some examples of the kinds of reports that are there. But you can stay in touch either with the PIANC .org, the main site, or the PIANC.us, the PIANC USA site. And so there are also lots of congresses and conferences that you can participate in. We saw some of you at the Smart Rivers Conference in Memphis in 2025. And coming up is PIANC America, which I don't know if we have a date yet, but it's Brazil fairly late in the year. And that's fun, especially for those who want to practice your Spanish or Portuguese. So the last thing I want to mention then is, we have the main site for PIANC International out of Belgium. and that's pianc.org. And our very own PIANC USA is pianc.us. So we'll spend time on those sites learning more about what we do and how you can be a part of it. And then, of course, the last little square there is about membership, and there are lots of ways to be members. We have corporate members, so some of you, your company is a member, and you can get uh, the reports and things like that via your company. In other cases, the Corps of Engineers folks, you can ask the librarian to get you things as well. Or if you want your company to join, there are these corporate memberships, and we hope that some of you will uh, get on the phone and ask your CEOs to join if they have not already. So with that, I'll stop sharing my screen and we'll start with the real reason that you're here, which is Burton's and Kyle's talks. So, Burton.
Hey, Will, thank you very much for that and really appreciate it. Certainly appreciate the opportunity that PIANC USA is providing us and with the opportunity for Kyle and I to present, I think, this timely and informative information on sustainable practices for navigable waterways. Interestingly enough, this will be a shortened version of the presentations that Kyle and I both presented in a short course of the same name at PIANC Smart Rivers back in September of 2025 in Memphis, Tennessee. So certainly a shortened version, and we'd be presenting those highlights to you from that short course as we go through the next 40 minutes or so. So if you go to the next slide. So who are we? Who am I? Who is Kyle? Well, very, very briefly, I'm the research biologist in the environmental laboratory at the Army Corps of Engineers Engineer Research and Development Center. We are the R&D arm of the Army Corps of Engineers, and I'm physically located in Vicksburg, Mississippi. Among other things, all the roles that I play as part of the Corps of Engineers, I manage the dredging operations technical support program for the Corps, and I am also senior advisor to the Engineering with Nature program within the Corps. That program that seeks to find ways in which the Army Corps of Engineers can achieve our civil and military missions in a more sustainable manner. Also relevant to this topic today, I am actually also chairman of the Environmental Commission of PIANC. So Kyle, I'll turn it over to you briefly.
Great, thanks, Burton, and thank you all for joining us today. I'm Kyle McKay. I'm an environmental director at Woolpert. We're a large architecture, engineering, and geospatial firm on 5 continents with more than 3,000 employees. And at Woolpert, I lead efforts related to design and use of nature-based solutions and the growth of our programs on environmental data analytics. In a prior life, I worked with Burton at the environmental lab of the Engineer Research and Development Center, where my work was focused on very similar issues. My background is in both ecology and engineering, and I live and work in New York City. So today I'm excited to show you kind of 2 flavors of what we've got going. Burton's going to get us started talking about operational issues, and then I'm going to jump in on some design-oriented issues. So back to you, Burton.
Hey, Kyle, thank you very much for that. And so our agenda today is going to cover 3 primary topics. The first topic is going to be on sustainable navigable waterways, talking about what is sustainability, and then PIANC's history related to promoting sustainable waterway management. After that, I'll be transitioning then into sustainable sediment management, talk about the PIANC Act and other activities related to that, particularly through the beneficial use of dredge material how the beneficial use of dredge material can be used to achieve more sustainable water transport infrastructure sector projects. Talking about technical resources, and then I'll be sharing roughly 8 case studies with you, showcasing some of the best practices in terms of sustainable sediment management, particularly in the United States. From there, Kyle is going to lead us on the technical biological bank protection. As he mentioned, he was a key contributor to that Inland Navigation Commission Working Group Report 128 on that particular topic. He's going to be covering, what are the solutions related to help reducing erosion on stream banks, particularly those related to nature-based solutions. He's going to talk about the technical resources that they are presented in that working report. And then finally, he is going to be showcasing the process that they developed for identifying alternatives for how to select which alternative is most appropriate for helping reduce bankful erosion for those particular projects in inland navigation. Okay, then moving on to our first topic. Will, I know all of us have certainly have a pretty good understanding of what this concept of sustainability is, and we've seen many definitions of it. But I really would like to get us kicked off on that to make sure we understand really where we're coming from a PIANC perspective. Sustainability is simply achieved by efficiently investing resources to create both present and future value. And I would argue, adding to that, thinking about how that can be contributed by nature-based solutions would be for people and the environment. If we think about sustainability, it's built on 3 primary pillars that you see there in the graphic below. Certainly environmental makes sense, but also looking for social and economic benefits and value associated with our waterborne transport infrastructure projects. And so we seek ways to incorporate those types of benefits beyond the underlying engineering benefits associated with the project. Okay, next slide. So we think about sustainability and the contributions of beneficial use of dredge material to help us manage our sediments in a more sustainable manner. And there are a number of ways which we can do that. Obviously, simply removing the material from the Federal Navigation Channel has substantial benefits associated with that. But we're seeking to seek benefits that go beyond simple removal of that material from the Federal Navigation Channel in ways, for example, that can reduce impacts from flood risk, looking for ways to restore ecosystems, and so on and so forth. And so the idea is to look for the value proposition, look for ways for our navigation projects, how they can become multi-purpose value projects. Certainly, when you think about sustainability, there are guideposts, if you will, there around the world that can lead us and guide us towards what sustainability really looks like. And certainly, the United Nations Sustainable Development Goals, I think, is a very well-known and respected way in which we can do that. You look at the 17 goals that you see there at the bottom right. Some of those may not be immediately thought of as being impactful and relevant to our projects, but when you look at the 169 targets that underpin those 17 goals, all of a sudden they start popping up and going, hey, that's very relevant to my project. That's very relevant to my project as well. So looking at the targets that underpin those goals, then you can realize, hey, my project may fit there very well. Okay, next slide. PIANC has actually a pretty long history in terms of sustainable development, certainly from the Environmental Commission, as you might expect, but also the Inland Navigation Commission, the Maritime Navigation Commission, and even the Recreation Navigation Commission you see there. Those working group reports that you see there are some key examples of how each of the 4 technical commissions of PIANC have contributed meaningful to the sustainable development of the WTI sector for the last essentially 25 years. And two of those reports are basically, we're going to be highlighting two of those reports more than the others as we go on through our presentation here this afternoon. Okay, next slide. Okay, then moving on to sustainable sediment management. One of the key precursors, I think, to increasing sediment beneficial use, particularly in the U.S. and particularly within the Army Corps of Engineers, is the release of that command philosophy notice in 2023 by our commanding general at the time, General Spellman, saying, hey, we need to try to achieve 70% beneficial use by the year 2030. So that command philosophy notice was codified in our Water Resources Development Act in 2024 that you see there on the lower right in section 1130. It codifies that, hey, we should ensure that not less than 70% by volume, that's measured in cubic yards, of suitable dredged material obtained from the construction or operation and maintenance of water resources development projects is used beneficially. So we really have really good policy changes that very recently within the United States that really enables us in ways to increase beneficial use that may not have been present before. Okay, next slide. That is certainly true with the U.S., but also in other countries around the world. Certainly those PIANC members that are part of the Environmental Commission. We look at sediment beneficial use here as basically being linked to a number of features associated with sustainability, including, for example, circular economy, our attempts to adapt and mitigate to a changing environment, also increasing potentially biodiversity, and then also potentially certainly a foundation of nature-based solutions. Okay, Will, next slide. Speaking of nature-based solutions, I really like this graphic a lot because it does, I think, for me, a pretty good job of helping us really kind of describe what nature-based solutions look like as a spectrum across a wide range of project types that we have, that historic but also current. Going from the gray conventional engineering on the left-hand side, essentially, your project or your scheme has little or no ecological consideration. There is no intent there to create value beyond the underlying engineering objectives of the project. But as we work our way then to the right here, we go greening the gray, those features that are incorporated into conventional projects that create value beyond what was originally considered. And then we move on to hybrid, prompted recovery, and then natural infrastructure, the mangrove forest, the sand dunes, the rocky shores, and so on and so forth. So because there is so much existing infrastructure around the world, a lot of the opportunities are going to be during repair, modification, or redesign of existing infrastructure. So a lot of the opportunities are going to be greening to gray and hybrid solutions. Okay, next slide. I like this slide too because one of the key characteristics of all of our successful sustainable projects is this partnership and collaboration. This is a great example. The 7 Mile Island Innovation Laboratory along the New Jersey coast in the United States. Certainly there was a conversation that was taking place, but it was accelerated by Hurricane Sandy. Those named storms as examples certainly create challenges for us for our navigation projects, but it also creates opportunities. And so they really took advantage of that and say we had damage not only to the navigation channel, we had damage to the coastal wetlands and take advantage, then beneficially using that dredged material. And this is removed from the federal navigation channel. And let's try to restore some of the damage that happened then to those wetlands in coastal New Jersey, because it's not only about restoring the ecological value associated with that. The communities are relying on this natural infrastructure to help reduce and blunt all those forcings coming off of the Atlantic Ocean. So this was much more value just beyond the ecological. Okay, next slide. There are a great number of resources that are available to us and to you. I really encourage you to take a look at that. This is mainly focused on the Engineering with Nature website and program within the Army Corps of Engineers, looking at our Engineering with Nature atlases and other tools and resources that are available there. We're certainly, PIANC also is involved in LinkedIn, so you can get information there as well. What I really want to point out to you, though, is the Working with Nature page on the PIANC website. This is publicly available. You do not need to be a member to access this part of the website. It gives you a sense for what the Working with Nature philosophy is all about and what we are doing to encourage and enable Working with Nature philosophy to incorporate it into our navigation projects. Also associated with Working with Nature, realize we have a Working with Nature certification program. Some of you dredging projects, and I know who you are, we're going to remain nameless here. You are sitting on these projects that could be Working with Nature certifiable. And so there's a form that you can fill out there to try to get your project to be certified consistent with Working with Nature principles. The other good news there is all certified projects between now and 2028 are going to be then nominated for the Working with Nature Award that's going to be rewarded in our next World Congress of PIANC in 2028 in Antwerp, Belgium. So it's a great time to think about submitting your form to get your project certified for Working with Nature. If you need information about how you might do that, don't hesitate to reach out to me, and I'll try to provide some additional information for you. Okay, well, next slide. That goes then into transitions into the projects that I'd like to share with you. These are a wide variety of scales and geographies that is meant on purpose, but the idea is to show you the best practices, particularly in the United States, and how we're achieving sustainable sediment management here in the country. Okay, next slide. The first one is going to be in the Great Lakes region. This is Cat Island in Green Bay, Wisconsin. We had a situation over the decades where there was a natural chain of islands called Cat Islands that were essentially being lost because of a lot of natural forcings coming in this part of Lake Michigan. When you lose those islands, you lose all the value associated with them, the environmental, the economic, and also the social. What was important, though, too, is those islands were blunting a lot of the forcings coming off of Lake Michigan that would have otherwise impacted the Port of Green Bay. So when you lose that natural infrastructure in the form of islands, you lose also that ability to reduce those forcings on the port. And so a big advantage then to restoring the islands, as you see here, is you can then restore those benefits, certainly the environmental, the ecological, and also the social. The advantage that we have too, certainly in our Detroit district, who was a big part of this process, they ended up gaining 20 or 30 years of dredge material capacity, over 2 million cubic yards in terms of restoring this Cat Island chain. So an excellent triple win bottom line outcome here in the Great Lakes. Okay, next slide. Another example on the Great Lakes, this was a situation where we had a confined disposal facility that I believe was at capacity, but it was essentially overtaken by non-native species. And so the idea is like, hey, let's try to reclaim that and beneficially use that and restore it in ways that can create much more additional value than would have otherwise considered. So in addition to transitioning the land side of the CDF, we also use beneficial use of dredge material. You can see the natural infrastructure there in terms of the root wads to help stabilize the bank line there. What was important here also is this particular project, it was very, very close to community interactions and the local community. And so you've got recreational, real estate, improved quality of life associated with this restoration project as well. So a lot of multiple benefits coming out of the restoration and transformation of this combined disposal facility. Okay, next slide. Another great example of keeping the sediment in the system using natural processes to enable more navigation is a great example in Horseshoe Bend. This is in the Lower Atchafalaya River in coastal Louisiana, south of Morgan City. The idea here, the great idea that our New Orleans district had is they knew enough about the local hydrodynamics of the system. Is that if we place this material in the center of the river and allowed the river's energy then to relocate that material, it created a riverine island that you see there in the lower left-hand corner. That created a multitude of benefits, including creating a deep, reliable, and narrow channel on the right-hand side of that would be east, such that the Coast Guard permanently realigned that channel. That had multiple benefits, essentially unrelated to environmental. So you're reducing long-term dredging requirements. This was an annual dredging requirement on the tune of about $4 million. So you can see the millions of dollars of cost savings. So we're now, New Orleans district is only dredging about once every 4 to 5 years. So a great reduction in dredging requirements. So we're going from a very unsustainable situation to something that's very, very sustainable. And you can see basically as they continue slowly over time, continuing to add material in that part of the river, you can see the island has continued to grow with additional placements over time. Okay, next slide. Raleigh, Mississippi is another good example. Hey, this is just 100 or so miles south of where I sit in the state of Mississippi. But I tell you what, these barrier islands that we have played an important role wherever they are, not only in the U.S., but also around the world, because these barrier islands help blunt those forcings, particularly from Hurricane Katrina and other named storms. Because if they weren't there, the billions of dollars of damage would have gone up exponentially. But they've been hit hard by these natural forcings. And so the Mobile district, when they had a chance to, hey, when we have these navigation projects, let's use that material beneficially in ways that helps restore the island, all the benefits and value associated with that island, the economic, the social, certainly the recreational value, the environmental, and also that island's ability to blunt forcings from future storms in those, and those potential impacts on coastal Mississippi. So a great project. Here you can see a close-up example there at the bottom photograph. And on top of that, we have also created some future placement opportunities here as well. So additional beneficial use associated with the island is there in the future for us as well. Okay, next slide. Fort Pierce Island is a great example. The way, the nature does not draw straight lines. And so if you ask yourself, am I going to design and build a breakwater that's a straight line? Well, I personally would encourage you not to, but look what they did at Fort Pierce Island. Again, another example of a marina that was severely damaged during a hurricane in 2004. So if we're going to create a breakwater here, how would nature build it? And this is a really good example of how nature would go about doing that. So 150,000 cubic yards of dredge material. Yes, we can use large rock, but look how they use large rock here to create not only the underlying engineering benefit, but also creating the other benefits as well, particularly on the environmental. You can see the ecological benefits that you see there that are printed. The marina was able to enlarge, that you see here, but the communities behind the breakwater also receive those benefits because future forcings are going to be reduced because of these breakwaters. So you get community risk reduction benefits as well. Okay, next slide. Moving on to the west coast of the United States in our Portland district of the core. The idea here, we have a federal navigation channel here along the lower Columbia River. And so they're looking for ways in which to beneficially use that material to help create habitat value, because we've lost a lot of those wetland and other habitats. And so let's look for ways to create not only land-based habitat, but also habitat nooks and crannies, if you will, that help create shelter for salmonids that, from the juvenile stage are certainly lacking those protective shelters. And so this type of project gives you an example of how we can achieve that, most multiple benefits as well. Okay, next slide. Our Huntington district has done an outstanding job in the last 25 years of not only keeping the sediment in the system, but looking for ways to increase, reduce their dredging costs, reduce their dredging need, but create multiple benefits as well. So they knew enough about the local hydrodynamics. They knew based on historical navigation charts where a historical bar was located. So the idea is try to restore that historical bar with placements of dredge material. And you can see where they're placing the material in the two top photographs. You say, hey, we're going to place this material here, and we're going to let natural forces of the Ohio River to shape that for us. And the bottom two photos, just a few short months later, gives you an example of how the natural forcing of the river can shape that essentially new bar configuration. What's also important for us too is there are native mussel populations just downstream of that. And so we want to make sure that any of that material that is being relocated by the river does not adversely impact those mussel beds, which makes perfect sense. But what is happening though is the relocation of that material is actually creating a more diverse and larger footprint of sand and gravel substrate, such that some of those native mussel populations are actually increasing as a result of these beneficial use placements. Okay, next slide. Another example, given as part of the Engineer Research and Development Center, we are actively doing research along these lines. And so this slide is just an example of some of the research that's going on you may not be aware of, but I think are very, very relevant, thinking about ways in which we can increase sediment beneficial use, particularly the fine-grained materials, looking for ways in which they can become components of cementous materials and creating natural infrastructure or hybrid infrastructure that you see here as an example. The beneficial use of dredge material to create these habitat structures to help, and when they're placed in the environment, to reduce those forcings and create habitat value of the infrastructure. So it's just an example of the ongoing research relevant to sediment beneficial use. Okay, next slide. It's really very important, and I'm just really excited that Jacob Berkowitz within the Army Corps of Engineers, he's a colleague of mine just down the hall, and co-workers asked the question a few years ago, okay, we have been beneficially using material within the Corps in the last 40, 50 years. What about those historical projects that were built in the 1970s? How are they doing now? So it's a great question. And they identified 6 locations within the United States and evaluated their condition after 40 plus years of them being on the ground. All 6 of these are totally unconfined. There's no rock, no large rock, no concrete, no steel, nothing associated with them. So how are they doing 40 plus years later? Turns out they're doing quite well, as a matter of fact. But a couple points to make is like, hey, they're being shaped by natural processes. They're creating great value at the time, but realize if we compare them to natural wetlands, they may not be very comparable, but they're providing multiple value functions. But so the bottom line here is we should focus less about mimicking natural conditions in terms of determining success for failure, thinking about, hey, what are all the benefits and value and functions that they're contributing in the current state. So great project and great research. Okay, next slide.
Hey, Burton. Oh, so this is your take-home message slide.
Yeah, good I didn't get with it, right? So I hope I gave everyone a sense that there may be many opportunities to apply sustainable sediment management practices. These are just some of the examples that we and others have worked on in the recent past and currently. So I think it's important for us that if you take the sediment out of the system, you're going to starve that sediment. So we want to try to keep that sediment in the system as much as possible. We need to focus our energy working collaboratively. And those collaborations, I think, are going to help accelerate the progress in terms of developing nature-based solutions, particularly as they include sediment. What's very, very important to us, too, is communication. We've got to communicate. not only do we have to collaborate, we have to communicate effectively what's worked, what hasn't worked, so we can then rely on those lessons learned and then continue to build on that research and that knowledge going forward to have even more effective, sustainable management of dredge material going forward. So that's all I had. So Kyle, I am pleased to turn it over to you.
Great. Thank you, Burton. That's great context for, pivoting to a slightly different subject. So Burton spoke about all of the different operational benefits associated with sediment management. And in this half of the presentation, I'm going to take us a little different place to thinking about design of a particular kind of feature. And we'll talk about multifunctional design and how to think through that process. Before I get started, though, Burton mentioned this notion of nature-based solutions and how it's a large spectrum of actions from kind of conventional to natural systems. And you might say, well, are all of these engineering actions? And I think there's kind of a logical development of the spectrum from its history in two different disciplines. So on the engineering side, we have kind of a historical version of engineering from, prior to the 1970s in this country, which was focused on kind of domination or control of nature. And here we see the more hard engineering paradigm of concrete and steel and straight lines. But over time, that notion has eroded, and now we see a lot more emphasis on expanded project purposes and resilience of designs, both in terms of natural systems, but also built systems. But if we hold that in our minds for just a minute, what we're saying overall is that the engineering design approach has moved from an entirely conventional or gray infrastructure solution toward more green infrastructure. But at the same time, in the conservation biology world, conservation started as a process of building walls around nature. And if only we could just conserve enough of it away from people, that it would save biodiversity and conserve life on Earth. But over time, the conservation community has increasingly acknowledged how people are a part of this landscape too. So even in the conservation arena, we see an increasing acknowledgement of the role of hybrid systems and people and nature sitting side by side. And the point I'm trying to make is that this outgrowth of a spectrum of natural to conventional solutions emerges from its history and its roots in these two different fields of practice. And we can see examples of this throughout river management. Today, I'm going to talk about one specific example, which is stream bank erosion reduction. And people have been living along rivers for thousands of years and struggling with the notion that rivers move. And often erosion reduction has been taken on through a huge menu of options. And what I want to point out here is that as we've learned more, our guidance has evolved alongside of these fields of practice. And here's a few select examples of guidance over the years, ranging from British waterway guidance in the late 90s, emphasizing planted riprap and the role of stone and plants together, through German guidelines, US guidelines, all showing an increasingly diverse set of materials in play and arranging them in different ways, whether it's willow mattresses or root wads or actions in the river, like, say, bendway weirs or other features. But if we take a step back and think for a moment, what can we learn from all of this existing guidance? And I would say there are a few key things. One is that when we talk about any one dimension of a river, like, say, stream bank erosion, we can't isolate it from the rest of the system. That even guidance documents on riverbank erosion often emphasize the role of in-river management, this notion of a system of projects working together that Burton was emphasizing. Secondly, we can look to this guidance and say, oh, there are a lot of different materials at play. We have concrete, steel, rocks, and we've got soil stabilizers and geotextiles, and we've got vegetation, and we've got in-water vegetation and large wood. And what we're doing is mixing those in different ways, and that's what's creating our spectrum of green to gray techniques or conventional to natural. And in the middle, though, is the majority of what we're doing. It's this blend. It's a hybrid of approaches for managing riverbank erosion. I think of it like when you go to bake in your house. If you're making cookies, cake, or croissants, you're using some combination of flour, sugar, butter, milk, and eggs. But the ratios you use it change depend on what you want the outcome to be. And it's kind of the same thing in the riverbank erosion literature, but not with cookies as the outcome. So into this fray comes PIANC, and in this case, I'm going to tell you a little bit about some work that was produced under INCOM Working Group 128. And this group was led by Dr. Bernhard Songren out of our German colleagues, our German chapters of PIANC. And after years of working on this topic of technical biological bank protection, ultimately the working group produced 3 big volumes of guidance on design and implementation of these features. And I can't tell you about everything today, but this 3-volume set talks about the library of methods that are out there and recommended. It talks about how to categorize them and think about the differences among them. It provides case studies globally. And then it says, here's kind of the cookbook for thinking through the design process. And that's what I'm briefly going to give you a sneak peek on today. So step 1 of that process, and this will mirror a lot of what Burton was suggesting, which is that step 1 starts with figuring out what the outcomes are and the performance goals. And it's important to understand that those are sometimes different, that maybe stakeholders are more interested in the outcomes of, say, a functional ecosystem or reduced bank erosion, whereas the engineering design may need to emphasize the performance goals, things like what is my risk tolerance, what's my design storm, what are the changes in boundary conditions that my site might feature in the future. And this conversation in step 1 really sets the stage for expectations with stakeholders, as well as the feasibility of different actions and how we might analyze them. But now that we've got good objectives, we can pivot towards understanding our site, and in particular, from an engineering perspective, articulating what our boundary conditions are. And as we think about different waterways, we may have a free-flowing waterway versus a pooled system. In an ecological context, we may have a temperate zone versus a tropical river. And in a social context, we may be in a highly confined urban area or a wide open river corridor. So we're articulating what those boundary conditions are as we work towards what designs are going to fit in that system. In step 3 of this process, we're diving in on what measures we might find useful at this site. And the working group produced a set of spreadsheet tools to help screen measures. And in particular, the worksheets and toolkit helps look through over 25 different types of measures that were in use, wide use globally, as well as 34 case studies and 6 detailed case studies. And the toolkit helps think through, is this feasible for my site, and is it suitable for the project objectives I had? So we're screening down those measures and figuring out which ones are most appropriate. Now that we've got a subset of measures that we're looking at, we can start to compile data on those and think about how they perform in the landscape. And the easiest way to do that is to think about how they've performed elsewhere. So in this step, the working group recommends going to those case studies that we have details on and looking at what the boundary conditions were and the physical performance and ecological performance at other sites, and thinking about how that would or wouldn't translate to your particular site. I think of this step as the step that a real estate appraiser might undergo when estimating the price of your house. They would look around to other houses in the neighborhood and they would say, how much do those houses cost and how are they similar to the one that I'm estimating the price for? And that's roughly what's going on here, is looking at other sites and how that performance might translate to your particular focal site. The fifth step will resonate with every engineer, which is going through those different knockout criteria or figuring out what constraints exist at a site. Often design is as much about minimizing constraints as it is maximizing objectives. So there are, of course, a litany of constraints that may make your site harder to design at or less of a translation between those examples. So this step is really emphasizing, are there reasons not to use a specific measure? But now we've gone through those sort of clear-cut different types of bank protection. But this is where the design process gets creative. We can start blending those, and we can start to, cook a little bit beyond the recipe, so to speak. Instead of just thinking of it as, say, a willow mattress or a longitudinal dam, maybe we can have a blended design at our particular site. And this is where we start to see those hybrid features emerge and why hybrid features are increasingly common. And then finally, once we have our design alternatives, we can go back to comparing those designs relative to our objectives. So in this step, the working group, again, provides a set of tools to help users think through the utility of a given design relative to technical outcomes, social outcomes, as well as ecological outcomes. And these tools, in addition to being useful for the engineering or the design team, also provide a starting point for that dialogue that Burton mentioned with stakeholders about how are we thinking about the site versus how other people are thinking about the site. So what are some take-homes from Working Group 128 that might translate more broadly about nature-based solutions or about sustainable river management? One for me would be that this dichotomy between the ecosystems over there and infrastructure over here, that erodes every day. We're increasingly seeing working landscapes where we have social outcomes and we have environmental outcomes, and our projects affect all of those. And so this notion of restoration over here and infrastructure over there, it's not really needed anymore. We need to be thinking of both and. How do we include all of those outcomes together? Second, occasionally people will suggest that there is no guidance for nature-based solutions. We couldn't possibly use those methods. I would say that's, generally speaking, quite false. River engineering has a deep, deep history of aligning natural processes with engineering design. And there's often a rich history of guidance in these subjects. However, as fields mature and as our body of knowledge grows, so too does our design approach. So there's always a need for new or emergent design methods, and programs like the Engineering with Nature program are investing in that appropriately. Third, while more objectives are in play, repeatable design processes exist for these features. I feel like sometimes engineers are being told, well, just keep adding objectives, add objectives, add objectives, and it gets harder and harder to design. But if we work through a logical set of steps like the ones I showed today, I think there are ways to get more repeatable designs out of those processes. So from our presentation today, I hope you heard a few themes. So Burton talked about more operational issues with sediment, and I talked about more design issues with bank protection. And both of these are examples of sustainable practices representative of kind of broader trends in our field. And so our point with this presentation is just to get you thinking along these lines, not to say that these are the only two sustainable practices in rivers, but instead they're representative examples of how the community is evolving through time. And overall, for me, this notion of sustainable waterway management focuses on doing more with our designs and making our designs more and more multifunctional and better performing through time. And as we think about that, we're adding new objectives like ecological outcomes and social outcomes, but the fundamentals of engineering design remain the same. I'll close by saying that PIANC has long played an important role in this community of practice, and I think it will continue to as our management of our rivers and inland waterways becomes more and more sustainable through time. So with that, Burton and I thank you for your time, and we look forward to our discussion today. So thank you very much.